Variable valve timing solenoids are critical components that control engine performance by managing oil flow to adjust valve timing. Understanding how they work and why they fail is essential for maintaining your vehicle. The VVT solenoid is an electro-hydraulic actuator that receives signals from the engine control module. It directs pressurized engine oil to variable valve timing actuators, allowing the engine to optimize valve timing for different operating conditions. Inside the VVT solenoid, an electromagnetic coil controls a spool valve that directs oil flow through various ports. A filter screen prevents contamination, though this is often an overlooked maintenance item that can cause failures. Modern vehicles, especially those with over 80,000 miles, frequently experience VVT solenoid failures. These failures account for 8 to 12% of all engine-related diagnostic trouble codes, making them a significant concern for vehicle owners. VVT solenoid failures present several distinct symptoms that drivers should recognize. The most common symptom is a rough idle, which occurs in 85% of all VVT solenoid failures. Other symptoms include poor acceleration, particularly during low RPM conditions, reduced fuel economy with typically a 10 to 15% decrease in efficiency, engine knock due to improper timing, advance, or retard, rattling noises during startup or idle, and oil pressure fluctuations. When VVT solenoids fail, the check engine light illuminates and specific diagnostic trouble codes are stored. The most common codes are P0010, P011, P020, and P0021. Proper maintenance is essential to prevent VVT solenoid failures. Use the manufacturer-specified oil viscosity, typically 0W20 or 5W30. For high-mileage vehicles, maintain maximum 5,000-mile oil change intervals. Clean VVT solenoid filter screens every 60,000 miles and address any oil system issues promptly to prevent costly repairs. Remember, 78% of VVT solenoid failures are preventable through proper maintenance. Oil change intervals exceeding 7,500 miles increase failure risk by 300%, making regular maintenance your best defense against these costly repairs. Proper diagnosis of VVT solenoid problems requires a systematic approach using 3 key methods: code analysis, live data monitoring, and component testing. Code analysis helps differentiate between electrical failures, like wiring issues, and mechanical problems, such as timing chain stretch or oil pressure issues. Live data monitoring allows technicians to observe VVT actuator response in real time, revealing performance issues that static tests might miss. Component testing involves checking solenoid resistance, which should typically read between 6 and 12 ohms. Values outside this range indicate solenoid failure. For rough idle issues, the primary fix is replacing the faulty VVT solenoid. This resolves the problem in about 89% of cases when properly diagnosed. Secondary checks include verifying cam timing and inspecting timing chain tension, as these components work together with the VVT system. Timing-related problems require a comprehensive approach. This may include addressing timing chain stretch, replacing the VVT solenoid, and servicing the entire oil system. When repairing VVT solenoids, always use OEM or OEM equivalent parts. Aftermarket solenoids have a 25% higher failure rate than original equipment. Advanced diagnostic systems and predictive maintenance technology can now forecast VVT solenoid failure up to 1,000 miles before symptoms appear, allowing for proactive repairs. Proper diagnosis and repair of VVT solenoid issues requires systematic testing, quality parts, and attention to the entire timing system for long-lasting results.